So now let's do this question. Find the voltage across the 4 ohm resistor. Okay. So here, if you want to apply source, so this 4 ohm resistor is over here, right? So do not touch this resistor, and you can apply source transformation anywhere except to this element. Do not make any change to this element. Okay. So here, if you want to apply source transformation, you cannot apply anywhere over here, right? Because remember that this resistor and this current source are not in parallel to each other, because in between these two elements there is a resistor. So therefore these two elements are not in parallel to each other. Okay, and so you should understand that this resistor is not in series with any of these resistors. Okay, so I think by common sense the only way of applying source transformation is over here, right? These two elements. This is a 6 volt in series with a resistor. Same current is flowing through both the elements. So this 6 volt is in series with this resistor, which means I can convert this into a current source with a parallel resistor. What is the value of the current source? I is equal to V by R, which is equal to 2 amperes. So which means this can be redrawn as a current source. There you go. With a parallel resistor of 3 ohm. This value is 2 amperes. This value is 3 ohm, and the remaining is the same. There you have a resistor, here you have another resistor, here you have a current source, and here you have another resistor, and you have another resistor over here. This is 4 ohm, this is 1 ohm, this is 2 ohm, this is 3 amperes. Okay, and this is 6 ohm, right? So now I think from here, you see, if you look over here, maybe you can combine these two resistors, right? These two resistors are in parallel to each other. You cannot combine these two current sources. Why? Is because these two current sources are not in parallel. See, there's a resistor in between them. So these two current sources are not in parallel to each other, okay? Don't get confused. But these two resistors are in parallel. See, this is a single junction. So these two resistors are in parallel to each other. So that means I can combine these two resistors. So if I combine these two, what will I get? 3 into 6 by 3 plus 6. That is 3 into 6 is 18 by 9, which is equal to 2 ohm. So these two resistors, if I combine together, it will become 2 ohm resistor. So let me redraw the circuit, or let me simplify the circuit. The circuit will now become like this, right? With another resistor over here, right? And this is 2 amperes, and this is 2 ohm, right? The rest is the same. The rest portion is the same. There you have. Here is the current source. Here is another resistor, and here is another resistor. Okay. And what is this? This is 2 ohm. This is 3 amperes. This is 1 ohm, and this is 4 ohm. See, this is the only change I made. Okay. So now let's see what I can do right now. Maybe I can now combine these two elements, right? Remember, this resistor and this resistor are not in series. Like I said, if you want it to be series, the same current should flow through them. You see, if a current is flowing through them, right? See, some of this current will be flowing through, it will get divided into 2 branches, right? So this is not, so if a current is flowing, it will get divided into these 2 branches. So therefore these two resistors are not in series, right? But these two elements are in parallel. So you can apply source transformation to this element over here, right? So by applying source transformation over here, this will become V into IR. V is equal to IR. V is equal to IR. So IR is 2 into 2, which is equal to 4 volt. So therefore I can combine these two into a voltage source with a series resistor. Or the circuit will become like this. A resistor with a series voltage source, and the rest is the same. This much portion is the same. This is 3 ampere. This is that resistor 1 ohm. This is that resistor 4 ohm. This is 1 ohm. This is 2 ohm. And this is that 2 ohm. And this voltage source is 4 volt. Okay. See, now the circuit became more simple. Now I can tell you that this 2 ohm and this 2 ohm are in series. Because see, the same current flows through both the 2 ohm resistors. So therefore now these two resistors are in series. So now you can combine these two. So on combining, what will I get? Let me see. 2 2 plus 2 is 4 ohm, right? I get 4 ohm resistor. So therefore I can redraw the circuit and make it more simple. It becomes a single resistor with a voltage source, and this voltage source is 4 volt, and the two resistors when combined, 2 plus 2 is equal to 4. The rest is the same. The rest is a 3 ampere. We have is a 3 ampere, okay, and this is a 3 ampere, and this is 1 ohm, and this is 4 ohm. There you have it, a 1 ohm and a 4 ohm. Okay, there, right? So now what I'm going to do is I'm going to convert this into a current source with a parallel resistor. Okay, I'm going to convert this into a current source with a parallel resistor. So how does it look like in that case? What is the value of the current? Current is equal to V by R. V by R, which is equal to 1 amperes. So which means this is equal to a current source whose value is 1 ampere, and a parallel resistor whose value is 4 ohm. The rest is the same. Okay, so now you see these two current sources are now in parallel to each other, right? Because both the ends have the same junction. So now I can combine these two current sources and they are flowing the same direction. Therefore 3 plus 1 is equal to 4. So this is 4 amperes. So this is, again I can simplify it, and this will now become a 4 ampere current. This is a 4 ampere current source, right? 4 ampere current source with a 4 ohm resistor. Okay, and this resistor is like this, and this resistor is like this. There you have it. This is 4 ohm, this is 1 ohm, right? Now what I'm going to do is that I'm going to convert this into a voltage source with a series resistor. Okay, this is a voltage source in series with the resistor. So how does it look like? So again, on combining these, this will become, what is the value of the voltage source? Voltage source I into R, which is, this is a 4 ampere current source with a 4 ohm resistor, and you will get 16 volt. So this is basically a 16 voltage source. So this resistor now becomes, or this element now becomes a series resistor, which is 4 ohm, and we have a voltage source which is 16 volt. Okay, the rest is the same. There, this is 4 ohm, this is 1 ohm. Okay, now if you want, you can add these two resistors and this will become 5, but that doesn't make much difference. If you want, you can simply apply Kirchhoff's voltage law over here. You will get the same answer, right? So applying Kirchhoff's voltage law, because my question is find the voltage across the 4 ohm resistor, right? Voltage across the 4 ohm resistor. Maybe if you want, I can just combine these two resistors. If you want, I can combine these two resistors. It's okay. No need for that. You can simply apply the KVL over here. So what is so if you apply mesh analysis, what you will get? I into 4 plus 1 plus 4 is equal to 16, or I is equal to 16 by 4 plus 1 5 plus 4 9. So 16 by 9 amperes. Current through the resistor is 16 by 9 amperes. Right? Current through this resistor. So therefore voltage across the 4 ohm, let me write that, current through 4 ohm resistor, 4 ohm resistor is equal to, what is 16 divided by 9? 1.778 amperes. 16 by 9 is equal to 1.778 amperes. That is the current through the 4 ohm resistor. Therefore, voltage through the 4 ohm resistor is is equal to 4 into 1.778 amperes. 4 into 1.778, that is the voltage across the 4 ohm resistor, I into R. So 4 into 1.778, right, is equal to 7.112. 7.112 volt. Okay, that is the answer. 7.112 volt. Okay.